Welcome fellow learners. In this video, we are going to implement DeepSeek-Coder-V2, a recently released open source mixture of expert code language model. We are going to implement this model in free Google Colab using Ollama. This model achieves comparable performance with respect to GPT-4 Turbo when compared in code-specific tasks. If you go through its paper, they have compared this model's performance with various closed source models such as GPT-4 Turbo, Claude 3 Opus, and Gemini 1.5 Pro model. This model achieves superior performance compared to these closed source models in coding and math benchmarks. This model comes up with 128K context length and also supports 338 programming languages. This model comes in two variants, the base variant and instruction fine-tuned variants. And also with respect to the number of parameters, this comes up in two variants, 16 billion parameter and 236 billion parameters. So these are pretty huge models. And we cannot run these models directly in our free Google Colab or either in our local PCs or laptops which are having either 8GB RAM or 16GB RAM or having 6GB or 8GB of GPUs. So we need to quantize these models. For the quantization part, we are going to use Ollama. So let's jump into the implementation part of this DeepSeek-Coder-V2 model in our free Google Colab using Ollama. So let's first connect to a GPU server. I have already connected to a T4 GPU. You can connect to GPU in this Colab notebook using this runtime. Then you can connect to a change runtime type, and then you can select this T4 GPU and then click on this save. I have already connected to this one. You can connect it from here. And the first thing that we need to do here is we need to install this Ollama. To install this Ollama, you can go to this GitHub page of this Ollama. Here they have provided a command to basically install this Ollama in a Linux server. You can copy this command and you can paste it over here. Just append a simple exclamation mark at the start of it and run this cell. This will basically install this Ollama in this particular Colab notebook. Once we have done this installation part of this Ollama in this particular notebook, we are going to use Python to use this Ollama and DeepSeek-Coder-V2 model to test it out in this particular Colab notebook. For that part, we can go to this Python page of this Ollama, where we can see how to use this Ollama in Python. So for that part, we first need to install Ollama using pip also. So you can copy this one and just paste it over here and run this cell. Now this Ollama will be installed in our this particular Colab notebook. Next, we can copy this code directly from over here, this particular code to run this Ollama in this particular Colab notebook. Copy this code and paste it over here. Just we need to change this Llama 3 to this DeepSeek-Coder-V2. To check the correct name for the DeepSeek-Coder-V2 in this particular Ollama, how they have used it in this Ollama, you can go to this web page of this Ollama where they have provided all the models available in this Ollama. So you can see like Gamma 2, Llama 3, Quen 2. These are models available, and then you can see this DeepSeek-Coder-V2 is also available. You can click on it, and then you can see all the different quantized versions of this model are available in this page of this Ollama. You can see like both of these 236 billion and 16 billion variants of different quantized versions of these models are available, like 4-bit, 2-bit, 8-bit, and so on. So we are going to use this 16 billion Lite version with 4-bit quantized and instruction fine-tuned one. So we are going to use this 16 billion Lite instruction quantized to 4-bit model. So let's click on this, and from here you can see this is the particular name of this particular model, DeepSeek-Coder-V2, available in this particular Ollama web page. So you can copy this one and just paste it over here. Just remove this particular Ollama run. And let's run this cell. So it shows like there is connection refused. So we first also need to connect to Ollama in this particular notebook. Now this Ollama application is being installed, but we haven't run that Ollama application in this notebook. For that part, we will be using this sub process because we don't want this Ollama to restrict our this main thread. So for that part, we are going to create another process, and to create another process, we will be using sub process. And from sub process, we can directly popen. So process.popen, and then we can pass this Ollama serve. this command will basically run this Ollama in this particular notebook. We also need to pass this cell equals to true. So now run this cell, and this particular Ollama will be running in another process of this particular notebook. Now we will be having this Ollama running in this particular notebook. Let's run this cell, and we will see output of this. Okay, so it shows that DeepSeek-Coder-V2 is not found over here. So for that part, we first need to pull this particular DeepSeek-Coder-V2 in this particular notebook. So one thing I missed it. I just need to copy this one, and then we can run it directly over here. And this will basically pull that particular basically DeepSeek-Coder-V2 model in this particular Colab notebook. Now you can see this is basically downloading this model. And if we go to that page, it is of around 8.9 GB size. So this will take a while, and let's wait for a while. So, okay, so now you can see it has downloaded this model and successfully fetched that model from this particular Ollama, and it is now running an interactive cell. So we need not to use that. So just interrupt this execution, and let's run this particular Ollama using our Python code. So now let's run this cell and let's see. Okay, so it's again giving us this error. So it might be that sub process has been closed or basically killed, because it was being used for earlier process. So let's again use run that sub process dot open, and then pass that Ollama serve, and then pass another argument set equals to true, and then run this cell. This will again run over this Ollama in this particular notebook, and then now run this particular cell. Now you will be seeing this particular Ollama is able to use this DeepSeek-Coder-V2 model, which is basically quantized to 4 bits, and it is instruction fine-tuned model. So the query is simple: why is the sky is blue? And let's wait for a while. It might take a few seconds to answer this query. Now you can see it has given us this response. But this model is basically a code language model. So instead of this, let's ask some different questions, like write a bubble sort algorithm. Okay. So let's see how does this gives us the result, and does it give the correct algorithm or not. So let's wait for a while. Okay, so it has given us the result. You can see first it has given us the pseudo code, and we didn't mention any particular programming language, but even then it has given us code in Python language. So let's copy that code and paste it in our code cell and see if it has given us the correct code or not. So let's simply pass an array. So let's pass an array which is unsorted, like 5 to 1, or then something 10 or something. Let's pass this array to this particular function and see if it is able to sort that array or not. So you can see it is able to sort that array, and you can see like it is correctly using this bubble sort algorithm. So let's ask a little difficult algorithm, like write edit distance algorithm. Okay, so let's see is it able to write that edit distance algorithm correctly or not. So like we also need to consider, like we are using this quantized version. So might be like the answers may not be as accurate as it is with the full precision version of this 16 billion parameter of DeepSeek-Coder-V2. So now it has given us this code. Let's copy this code. Okay, this one, and also this one. Okay, they have already provided some example, and let's see. Is it able to gives us the correct result or not? Okay, so it is giving us 0, which cannot be correct. because you can say kitten and sitting are way much different than each other. So what could be the problem? This is not giving us the correct result. So like okay, it is using recursion. Okay, it is taking these one, but it is not adding any cost to this. So this might be a problem. So you can see like it is not giving the perfect result when we are using the quantized version. Okay, so like DeepSeek people have also provided a UI where we can use this Coder V2 directly, and they might be using the bigger version of this particular DeepSeek-Coder-V2 model. They might be using that 236 billion parameter one. So let's ask same question to that model, and let's see if it is giving correct result or not. And let's copy this one and paste it over here. So let's see, it is giving us the code. Now it is writing the code over here, and it looks similar till now. And let's see if it is able to write the exact correct code or not. Okay, now you can see it has added the cost and the basically cost or distance, you can say over here, like 1 plus this one, which is missing in that particular code. So let's copy this code and paste it in our notebook, and let's see for the same problem what is the distance that it is giving. So now you can see it is giving us the edit distance equals to 3. So you can clearly see that sometimes the quantized version might not be as accurate as the full precision versions. So but for the learning purpose or for the basically the testing out purpose, we can always use that. And if we are need to use this quantized version, it is suggestible to basically fine tune this model on the basis of the domain specific task, such that they can perform better and have less hallucination. So great. Thanks for making till the end of this video. Goodbye until the next time.